Hello there, I'm Mr. Saem Sutarek. Today we'll be discussing a very important topic, uh, which is the subnet masking. Um, let's have a look at it. So, first of all, we have to know why do we actually use subnet masking? What is the importance of subnet masking? Remember one thing that the subnet masking that we're discussing over here will actually be uh, relevant for our IPv4. Okay, so it's used for your 32-bit IPv4 address, and we'll see how it can actually help in a network. So whenever we refer to an IPv4, this is actually known as an octet. Okay, so it goes from 0 till 255. So which means you can connect 255 devices in one octet. So if we look over here, this diagram, you can see over here is that we have devices over here, we have the devices over here. Okay, so they have their own host address. So your um, subnet mask consists of a host address and also your network address. So there are different classes which I'll discuss with you as you speak further. You should know is that this is the example of a host address, and let's say this is my network address. Now, what do I mean by that? Let me first of all explain this, then I'll come back. So when we talk about subnet masks, we do have classes concept, and in class A, we actually have 255 as our net address, network ID, and we have these as the host ID, which means is obviously in this particular case, I can connect 255 multiplied by 255 multiplied by 255, which is around like 60,000 something amount of host computers that I can connect with one network ID. So obviously in class A, we are referring to most of the ISPs who would be giving connection to households. So these are the usable hosts that we have. I can use this much amount of hosts. Like I gave you the example, where large number of hosts are required, we'll go for class A. Class B obviously would have 255 into 255 net as the network portion. So obviously this will be utilized. And the usable host ID in this case will be 255 into 255. Okay. So this is the amount of hosts that I can have in class. Okay. We can use these for multiple places. Uh, for example, uh, wherever we have to do public surveillance cameras have to be installed in that case. Class C will obviously is used in your local LANs. Your class C will obviously have the minimum number of host ID, which is 255. So you will have these portion to be used as your host ID, network ID, and the following to be used as your host ID, as you can see over here, right? Let me come back to this. So whenever we refer to an IP address, this is what we actually means, but computers will always understand this form. So whenever we refer to 192, we actually refer to this in the binary form. And obviously, those of you coming from the computing background, you probably have an idea that if you put this into a conversion grid, you will obviously get is 192. So the following binary numbers actually represent 192. Okay, and the following binary numbers represent 168. The following is 1, and the following obviously would be 0. Yes or no, right? So the reason why we're discussing this is because we have to discuss our next topic, which is the classless interdomain routing. Classless interdomain routing was very important because if we had some unused addresses, they would actually be covered up by CIDR. So it's simply we can do is we can represent CIDR through this notation. Now, what does 26 represent over here? 26 actually represents in this 32-bit. Well, by the way, I just told you before that your IPv4 is a 32-bit. So over here, I have 8, I have 8, and I have 8. So this comes out to be 24. And 2 bits actually I'm taking from here, which is 26. So what can actually happen is I can actually use from this network portion as well. Okay, so you can see what here is that if in this subnet mask, which I'm referring to class, okay, class A, I have 8 bits for the network, okay, and I have 24 bits for the host, like we just talked about class. In class B, we just talked about we have 16 bits for the network and 16 bits for the host. So, uh, as I told you before, if I have 1, 1, 1, 1, 1, 1, 1, okay, this will be equal to 255 if you put this into a conversion grid. So 255, 255, well, for the network and 6 bits for the host in class C, which is most commonly used class for networking. Class C, you have 24 bits for the network and you have 8 bits for the host, right? So this is what you have. Okay. Class D is usually used for research and all that. So this is the way your CIDR notation is basically derived. Okay, that's the way. So obviously, what if I add these two together? This is actually 192. Okay, 128, 128 plus 64 is equals to 192. Okay, so this is how we have derived this from this CID notation. So 255.255.255.192 in CIDR notation actually is equal to this. So slash 26 means the same thing. You could actually try something on your own. I mean, try making a CIDR notation for this, convert this into subnet mask and see how the subnet mask is. Then you can try with 29 as well, experiment and see what do you have. You can mention in the comment box, okay, where I can tell you what the answer is if you have any confusion. So this is what we have for our A-level CS. Obviously, there's a lot more to it, but we don't really have to cover beyond this. I hope it's clear.